Good morning, students. Welcome back to our ICTs once again. So today we can discuss about limits. So mathematics first year. Myself, M.Balakrishna Reddy, JL in mathematics. TSRS&JC borabanda-boys. So we have to discuss today limits chapter from the calculus part. Okay. So then limits. Actually, this limits in this year continuity was deleted, but we have to discuss all those things. Actually, limits and continuity having the one 4 marks question plus two 2 marks questions, two 2 marks questions. So totally 8 marks. So this is the limits and continuity weightage chapter weightage. So first you have to know the what is the limits and the what is the continuity. Before that you have to know the what is the order paid, what is the close interval, what is the open interval. Just you have to know that. So before I'm going to take a definition on limits. Limit. So let E is subset or equal to R. E is subset or equal to R. R is a real number. R is a real number. And a function E maps. E maps R. A function, F maps E to R be a function. F maps E to R be a function. That function having an element that is A belongs to R. So this A value lies in the R. So B such that A minus R comma A plus R such that set A. So intersection E. So is a non-empty set, non-empty for every R is greater than 0. For every R is greater than 0, which is saying that E subset are equal to R, E subset are equal to R, and let A belongs to R such that A minus R, A plus R, so that set A intersection E is a non-empty set. So which is nothing but if you substitute the R values or A values, then you will get some set. So for R greater than 0. Next, if there exists a real L, there exists a limit L satisfying the conditions below, then L is said to be a limit. Then L is said to a limit of a F of F at A. So if there exists a real L, that is L is nothing but the limit satisfying the condition below, then L is said to be a limit of F at A. So then given here, this is called epsilon. This is epsilon. We can say this as epsilon greater than 0. This is dou. This is dou. There exists dou greater than 0. So they given epsilon greater than 0 and there exists dou greater than 0 such that mod of f of x. This is a function in x minus L. This is a function in x, f of x minus L less than epsilon. So this is actually epsilon is greater than 0. So this function, this mod function is less than epsilon whenever x belongs to capital E and 0 is less than mod of x minus a is less than dou. Mod of x minus a is less than dou. This is the condition. Okay. So then in this case we say that limit of the function f of x as x tends to a, x moves to a exist and then it will exist and it is L and it is L and we write it as limit x tends to a. We have to spell that like this: limit x tends to a, f of x equal to L. Limit x tends to a, f of x equal to L, or f of x tends to L as x tends to a. So this is limit x tends to a, f of x, or we can say f of x function tends to L as x tends to a. Where x tends to a, the function moves to L. So that is the concept of this one. Next. So if L does not exist, there is limit x tends to a, f of x also does not exist. So this is the limit definition. So you have to know this is the limit definition. So this value, only this limit definition and the So notation for the limit. So this is most important. Next, let f maps e to r and g maps e to r are two functions. Let I'm taking two functions f and g and their e maps to r, e to r, sorry, e to r. So let a belongs to r. So any element lies in the real numbers be such that e intersection of, same in the previous one, so e intersection of a minus r, a plus r, such that set a so is a non-empty set for r is greater than 0. So you have to substitute the values, then this will be the exist of some element. Then let k belongs to r. Suppose that limit extends to a, f of x equal to l. This is the definition of a limit. So and limit extends to a, g of x equal to m, g of x equal to m. Then the following are true. So then the following are true. So then first limit extends to a, f of x plus g of x. So I can write this one as f plus g of x. Limit extends to a, addition of a limit function. So this is addition. So limit extends to a, f plus g of x equal to l plus m. Whether because of f of x value is l and the g of x value is m. So just you have to add it. So this is a subtraction. F minus g, limit extends to a, f minus g of x equal to l minus m, l minus m. And this is a multiplication. Limit extends to a, f into g of x, that is nothing but f of x into g of x, that is equal to lm. And the limit extends to a, any scalar is multiplying with a function. If you take f of x here, you can take g of x also there. So then if you take f of x here, limit extends to a, k into f of x equal to k into l. If you take limit extends to a, k into g of x equal to k m, k m. So next, and another function also defined in the previous one. We defined two functions. Now another function will here. So that is if h maps e to r and let this value and let limit extends to a, h of x equal to n, h of x equal to n, which is not equal to 0, which is not equal to 0, then h is never 0, then h is never 0 in same e intersection of a minus or of comma a plus or, so that set a. So for some r greater than 0, so limit extends to a 1 by h of x. 1 by h of x is nothing but 1 by n. So this is nothing but limit extends to a 1 by h of x, 1 by, this is h of x. So this can be written as 1 by n. So that is nothing but I can write, and limit extends to a, f of h by x equal to, this can be written as, I'm only writing this one, f of x by h of x, h of x. So then this value equal to l by n. That is the concept. So addition, multiplication, subtraction, scalar multiplication as the division. Okay. Next, sandwich theorem. So sandwich theorem important. So just a statement important. Let e subset r equal to r, f comma g comma h maps e to r. So these three functions define in the same domain and the core domain. And let a is belongs to r. So a lies in the r. So besides that, same a minus r, a plus r, such that set a intersection e is a non-empty set for every r greater than 0. So then, so this is a condition. F of x is less than or equal to, f of x is less than or equal to, g of x is less than or equal to h of x. For all x belongs to e, so x must and should lies in the e, and x is not equal to a, x is not equal to a. And if limit extends to a, f of x equal to l, that is limit extends to a, h of x equal to l also. So same value, limit extends to a, f of x tends to l. So this value is also l, and the limit extends to a, h of x value also l. Then limit x tends to a, g of x exists and equal to L. So clearly says that here limit x tends to a, f of x, and the same value of this value. So limit x tends to a, g of x, this is equal to limit x tends to a, h of x, So these all are values L. So that is the sandwich theorem. Okay. Next, let a minus r a, sorry, bracket is missing here. Here, a minus r, a plus r, such that set a for all r is greater than 0. So from the previous one, so and f function f maps e to r, then limit extends to a, f of x equal to L, if and only if limit extends to a plus f of x equal to L, limit extends to a minus f of x equal to f of x. So this is a right hand limit, this is a left hand limit. So limits also have a right hand limit, and the left hand limit. So limit extends to a plus f of x equal to L, and the limit extends to a minus f of x equal to also L. Then limit f of x equal to L extends to a, f of x equal to L. Okay, this we can use in the problems. So then next, if limit extends to a plus f of x and limit extends to a minus f of x exist, then limit a plus f of x equal to, so this we can be right like this. So limit h tends to 0 and h is greater than 0, f of a plus h, this is the right hand value, and the limit extends to a minus f of x equal to limit h tends to 0, h is greater than 0, and this value is f of a minus h is the left hand value. So left hand limit, right hand limit. So that is the concept is here. So some important formulas for this chapter. So let n be a rational number and a be a positive real number, then x belongs to a, x power n minus a power n by x minus a equal to n into a power n minus 1. So n into a power n minus 1. This is the most important formula. So this is used in the 4 marks question. So limit extends to a, x power n minus a power n by x minus a equal to n into a power n minus 1. So then next formula. So limit extends to 0, a power x minus 1 by x is nothing but log a to the base e, log a to the base e. These are the formulas, and the one thing, limit extends to 0, sin x by x equal to 1, sin x by x equal to 1. This another formula, and the other formula will be there. So that is limit extends to 0, sin ax by x equal to a. So this we can use this formula in the problems. So this is important. These both are okay. So otherwise we can write this is 1 is there. So I'm writing here. If a substitute there, so I will get a. These are important formulas. So next we have to go to problems now. So first problem, limit extends to 0, limit extends to 0, 1 plus root of 1 plus x minus 1 by x, root of 1 plus x minus 1 by x. Just here you have to do rationalization in this question, given that limit extends to 0 under root of 1 plus x minus 1 by x. So then you have to do rationalization with the 1 plus x numerator. So you have to rationalize this one. So for this one, so I'm doing this. So this is the left hand side value, limit extends to 0, root of 1 plus x minus 1 by x, then limit extends to 0, root of 1 plus x minus 1 by x. So I'm rationalizing here. So root of 1 plus x plus 1 by root of 1 plus x plus 1. So this is a, b, a minus b into a plus b. So a square minus b square. So a square minus b square. Then you will get from the numerator value I'm writing 1 plus x minus 1. So square roots will be gets cancelled. So then I will get 1 plus x, and the 1 square minus 1 square is this one, a square minus b square. That's why I will get this value is 1. So and this value can be written as 1 by x. So I can write this is 1 by x, and the denominator value is nothing but root of 1 plus x plus 1. So now, so limit x tends to 0, the left hand side value is root of 1 plus x minus 1 by x. So from this one, so here in the previous one, so here observe this one, this plus 1 minus 1 will get cancelled, plus 1 minus 1 will get cancelled, this one gets cancelled. So you will get only x. So this x will also cancel. So then you will get 1 by under root of 1 plus x plus 1. So this value will get, so that is limit x tends to 0, 1 by x of x by under root of 1 plus x plus 1. So this will be gets cancelled. So then now I will get this value, limit x tends to 0, 1 by root of 1 plus x plus 1. Okay, now we have to apply the limit. So then just you have to replace x value as 0, x value as 0. So just substitute there, then 1 by root 1 plus root 1. So root 1 value is always 1, 1 plus 1 is nothing but 2. So 1 by 2. So this is the answer. Limit x tends to 0, 1 under root of 1 plus x minus 1 by x is nothing but 1 by 2. This is the solution. Just this is a rationalization method. Rationalization method. Okay, please observe this again. So this is given that, so then you have to rationalize with root of 1 plus x plus 1. So from that one you will get a square minus b square, and simplification you will get these values. So 1 by x of x by under root of 1 plus x plus 1. So then you will get limit x tends to 0, 1 by root of 1 plus x plus 1. Then you have to apply the limits. So as x tends to 0, then you have to substitute the x value as 0. Okay, so from that one you will get 1 by 2. This is the answer. So next problem. So same as it is. So but is a different formula will be used. So limit x tends to 0, 3 power x minus 1 by under root of 1 plus x minus 1. So for this one, you have to do same rationalization method here. But in the previous sum, we are numerator rationalization. Here, denominator rationalization we have to do. So for that one, you have to rationalize with the root of 1 plus x plus 1 by root of 1 plus x plus 1. So then multiply and dividing with this one. So is this nothing but a square minus b square. This is a minus b into a plus b. Okay, so a plus b into a minus b, a square minus b square. Okay, then multiply, rationalizing with root of 1 plus x plus 1. This value, numerator value, root 3 power x minus 1 into root over 1 plus x plus 1. So this value, and the denominator value is nothing but root will gets cancelled, then 1 plus x minus 1, 1 plus x minus 1. This will gets cancelled, these two will gets cancelled. So limit x tends to 0, 3 power x minus 1 into root of 1 plus x plus 1 by 1 plus x minus 1. Then 1 will get cancelled, then you will get x in the denominator. So in the previous one we have that a power x minus 1 by x value, that is, so now we have to apply that formula. So this is the value we give, this is, so I'm taking here, taking first, this is limit x tends to 3 power x minus 1 by x into root of 1 plus x into 1 plus x plus 1. So then apply separately. This is limit f into g of x, that is limit f of x into limit g of x we can write. So that's why I'm writing. So and we have a formula in the previous, so that is limit x tends to 0, a power x minus 1 by x is nothing but log a to the base e. So here you have to use for this one in the place of a. So in this place of, here we have a, but in this place then we have 3. Okay, and you have to substitute the value x tends to 0, x tends to 0, then just apply the limit here. 1 plus 0, root of 1 plus 0 is nothing but 1 plus 1 into log of 3 as per the this formula, log of e to the base e. So this value is nothing but log 3, then so 2 log 3. So 2 log 3, we can use the log formulas, logarithm formulas. Log of a power m is nothing but m into log a. Okay, so then log power 3 square, we can write log of 3 square. Log 3 square. 3 square is nothing but 9. This is the required answer. So this is limit extends to 0, 3 power x minus 1 by root of 1 plus x minus 1 is log root or log 9. Okay, so this is the solution. So let's observe once again. Find the limit extends to 0, 3 power x minus 1 by root of 1 plus x minus 1. Solution for that one, given that you have to write and the left hand side value I'm taking, and you have to rationalize with root of 1 plus x plus 1. So from that one you will get the limit extends to 0, 3 power x minus 1 into 1 plus root of 1 plus x plus 1 by 1 plus x minus 1. So then 1 will get cancelled, then we'll get this value. So limit extends to 0, 3 power x minus 1 by x into root of 1 plus x plus 1. So from this one, we have to use the f into g of x formula. Limit extends to f into g of x is nothing but limit extends to 0, f of x into limit extends to 0, g of x. From that one, I can separate that one, and using this formula, so I will get this value. So and solve. So this value is nothing but log of a power m equal to m into log a. So then this is the answer. Okay. So compute 0 a power x minus 1 by b power x minus 1, where a is greater than 0 and the b is greater than 0. B should not equal to 1. Why? Because if it is b equal to 1, then the value, and otherwise x b value equal to 1, then this will be infinity. So this is nothing but in the previous problem we are used the one formula, that is the limit extends to 0, a power x minus 1 by x equal to log a to the base c. So we have to transform into that way. So just we have to do divide with x there. So we have to do divide with x. So we have to do divide with x. So I'm doing that. So given that this one value, so I'm doing divide the numerator and the denominator with x. So then this will be gets cancelled, same as will be there. So I can write, so in the formula limit of limit of f of f by h of x, last formula. So x equal to what we write, L by n. That's why I can write, I will use limit extends to 0, f of x by h of x, then I will write. So similarly here a power x minus 1 by x and the b power x minus 1 by x is there. So then I'm applying separately. So limit extends to 0 f of x by limit h tends to 0 f of x. So that's why I'm applying here. So this is nothing but, this formula is nothing but log a to the base e, This value is nothing but log a to the base b. Here b value is there. So just, so we are using that formula. We are using this formula. So limit extends to 0, a power x minus 1 by x equal to log a to the base e. From that one, I can write this value is nothing but log a to the base e, So this can be written as, log a to the base e by log a, log b to the base e can be written as log of a b to the base b. So we can write this value. So this is the answer. Okay. So observe this one. So just we have to transform into the required formula, and apply that formula. We will get the answer. This is very short answer. Okay. Next question. This is the most important, and this is limit extends to 0, sine of a plus bx minus sine of a minus bx by x, sine of a plus bx minus sine of a minus bx. So clearly we have to observe this is sine c minus sine d formula. Sine c minus sine d is nothing but 2 cos c plus d by 2 into sine c minus d by 2. 2 cos c plus d by 2 into sine c minus d by 2. Just we have to apply the formula there. For that one, given it's given, you have to write. So then, LHS value equal to, so sin C minus sin D. So sin C minus sin D. Otherwise, I can write sin of A plus B minus sin of A plus B. Sorry, this is minus. This is minus. So that is equal to 2 cos A sin B. 2 cos A sin B. That's why I'm writing. So this is A. This is B. This is A. This is B. I'm writing these values. So then that is sin C minus sin D is nothing but 2 cos C plus D by 2 into sin C minus D by 2. Apply here. Then you will get. 2 cos A into sin Bx by x, sin Bx by x. And we know the formula. So that is sine of limit x tends to 0, sine of ax by x value. Ax by x value is nothing but a. So in the formulas I said that one. So this is the formula, and this is constant term. I'm getting outside of the limit. So then, so that is the formula. Okay. So then, so as x tends to 0, then bx also tends to 0. So then here limit x tends to 0, this is the constant term. I'm writing outside of the limit. So this is value, and this can be limit x tends to 0 sin bx by x is there. So you have to write the limit will be changed as limit x, bx tends to 0, bx tends to 0, bx tends to 0 sin bx by bx into b. So otherwise we can write here, like this. So this value, so no need to multiply and dividing with b. So just you have to write sin ax is there, just you have to write b in the place of that one. Then you will get the value is b. So if you multiply and divide with this one, so you have to change the limit value here. Bx as. So if you don't, then you have to use this formula. So that value is nothing but, this is 2 into b is nothing but, this is a constant term. I'm getting to this value. So here 2b cos a, 2b cos a, 2b cos a. This is the required answer. Just one formula is there. So two formulas is there. That is sin c minus sin d formula, and limit x tends to 0 sin ax by x equal to a. So just use that formulas. Okay. This is a solution for the given question. So next question. Okay, this is completed. Next question. Limit, fifth one, compute limit x tends to 0, 1 minus 2nx by sine square nx. So before that going, we have to remind the formula of cos 2x formulas. Cos 2x formula. So cos 2x is nothing but, we have three formulas. That is cos square x minus sine square x. Otherwise I can write 1 minus 2 sine square x, otherwise I can write 2 cos square x, so here 1 minus cos 2x is there, so we can use this formula. So that formula is nothing but, so then cos 2x, I'm taking this cos 2x into right side, and the 2 sin square x into left side. Then cos 2x, this is 1 minus, this is 1 minus cos 2x equal to 2 sin square x, So this is cos 2x equal to 1 minus 2 sin square x. From that one, I'm transforming for 2 sin square x. I'm taking this value into left side and cos 2x value into right side. Then I will get 2 sin square x equal to 1 minus cos 2x. Okay. Then solution, this is, and the LHS value, I'm writing that one. So using that formula. So 1 minus cos 2x is there. So 1 minus cos 2 mx is there. So I can write that is 2 sine square mx, 2 sine square mx, 2 sine square mx. This is the formula. Okay. So then I'm doing here. Please clearly observe here. So 2 into 2 is the constant term. I'm writing outside, writing outside of the limit, and the limit extends to 0. We have sine square mx by sine square nx is only there, so I have to transform into a one formula. So we know that. So I'm multiplying dividing with the numerator is multiply dividing with the numerator is with the mx whole square, mx whole square. So denominator nx whole square, nx whole square. Just you have to do here multiply and dividing with m square x square or mx whole square for numerator. For denominator nx whole square, n square x square otherwise. So then that will be limit extends to 0, 1 minus cos 2 mx by sine square nx equal to 2 into limit of 2 into limit extends to 0, 2 into limit extends to 0. So then this value is nothing but this is sine square mx by m square x square in the previous slide. So then I can write this is a square by b square. I can write a by b whole square. I can write a by b whole square into m square x square as usually, and the denominator also we can write sine n x by nx whole square, sine nx by nx whole square into nx whole square. Then this is a formula we can use. Limit extends to 0, sine ax by x is nothing but a, otherwise I can write this is limit extends to 0, sine x by x equal to 1. If you have a here, then you will get a also. So if you want to have here, then you will get this one. If you multiply divided with a, then you have to change the limit value. Okay, so for that one, so I'm doing this. This value is nothing but 1. So whether because of use the formula of formulas, limit extends to 0, f of x by h of x equal to limit extends 0, f of x by limit h tends 0, h of x. From that one you will get this value is 1. This total value is 1. So that is 1 square is nothing but 1. 1 square is nothing but 1. So similarly from the denominator for this value, so you have to get the value, you will get the value is 1. You will get the value is 1. 1 square is nothing but 1, and the remaining values are m square x square from the numerator and the denominator n square x square. So these x square will get cancelled. X square will get cancelled. So then you will get to 2 into m square by n square. This is the required answer. This is the required answer. So please observe once again. I will repeat this one. So what is given that question? Limit extends to 0, 1 minus cos 2 mx sine square nx. So for that one you have to write given that and the left hand side value equal to, so this value how can we write, sir, this value? So here the value 1 minus cos 2 mx can be written as 2 sine square mx from this formula. From this formula, using this formula we can write like this. So and now we have to transform into a formula, that is sine x by x, limit extends to 0, sine x by x equal to 1. So for that one I have to do here, this is square term is there, so I have to multiply and dividing with m square x square from numerator. So for denominator n square x square. So then I'm doing that. So here, so I can write this is a square by b square. I can write a by b whole square. So into m square x square. Similarly in the denominator also a square by b square, that can be written as a by b whole square. So then this is the value. So 2 into limit extends to 0, sine mx by mx whole square into mx whole square by sine nx by nx whole square into nx whole square. So we know the formula, that is nothing but limit extends to 0, sine x by x equal to 1. So here same value is there. So you can write this value is, if you substitute the value, so for the numerator you can write this value is limit mx tends to 0 into sine mx by mx, so that value is 1. Okay, for the denominator value you can write limit nx tends to 0, so you have to change that one. limit nx tends to 0, then sin nx by nx whole square, that will be also 1. So this is square. So 1 is nothing, any change, so no change in that one. So then you will get that value is 2 is there. So similarly you have to write 2, and the values, this is m square x square. So m square x square by n square x square, then x square will get cancelled, then you will get 2 into m square by n square. This is the required answer for the given question. Okay, next problem. So compute limit x tends to infinity 11 of x cube minus 3x plus 4 by 13 of x cube minus 15 x square minus 7. So just we can say this answer is this one, only 11 by 13. So this is the direct method. So we can write. So whether because of he mentioned here, this is value is infinity, this value is infinite. So he mentioned there that value is infinite. So clearly you can take the value, this value, this is the answer. So due to because of this one. Okay, so then I will explain this one. So this is slow solution given that LHS value, and so from the numerator I'm taking x cube common, from this one I'm taking x cube common. Okay, so otherwise I can take, I can do multiply and dividing with x cube on numerator and the denominator. Otherwise you can take directly x cube common, then you will get x cube into 11 minus 3 by x square plus 4 by x cube. Okay, so here he mentioned x tends to infinity. Okay, so if x tends to infinity, if x values tends to infinity, so what is the mean by infinity? The value is nothing but undefined, so we are taking like this. So if x tends to infinity, then that value is 1 by 0, then 1 by x tends to, the value is tends to 0. Okay, so 1 by 0 infinity, 0 by 1 is 0. So that's why we can take these values will be the 0. So that's why we can take directly answer is 11 by 13. So just we have to do now. So this is the x cube by x cube and x cube by x cube, and the both the denominator and the numerator. So then you will get this value. So x cube is there, and the 11x cube by x cube, 11 minus 3x by x cube, that is 3 by x square, plus 4 by x cube plus 4 by x cube from the numerator. And from the denominator x cube is same, so 13 x cube by x cube is nothing but 13, and the 5 minus 5x square by x cube is nothing but 5 by x, and the minus 7 by x cube. So clearly from this one, this value is 1 by x are there, 1 by x is there. So that is the value. So why can we write, sir? This is condition. As x tends to infinity, 1 by x, 1 by x square, 1 by x cube, whatever it may be. So that will be tends to 0. That will be tends to 0. Okay. So sorry, this values, this is value, not this is x values, so not zeros here. So this is not zeros, so this will be get, so this value is zeros, so this value is zeros. So then the remaining value, this one only, remaining value this one, this is 3 by x, 3 by infinity, not here, this value is infinity, x tends to infinity. I am writing here, this value is infinite, infinity, these values are infinity. Okay, next. So this is a solution for the given question. So most important, so direct answers for question, these questions, these type of questions. So this is the question. So in the question, just you have to take the highest coefficient, coefficients are is the answers from the numerator and the denominator. So for that one explanation, limit extends to infinity 11x cube minus 3x plus 4 by 13x cube minus 5x square minus 7. From that one, just you have to take x cube or x cube common, or you have to multiply and divide with x cube. Then you will get x cube of 11 minus 3x square plus 4 by x cube by x cube of 13 minus 5x minus 7 by x cube. So from this one, we have to write the values are zeros like this. So then answer will be the 11 by 13. Okay. Next. So third and the seventh question. So limit x tends to 0. Limit x tends to 0. So cube the root of 1 plus x minus cube the root of 1 minus x by x. So generally this is called as second root, that can be written as, if it has like this x, so then you can write this is x power 1 by 2. So if he mentioned here the value, so you have to write that value is nothing but x power 1 by 3. Okay, so 1 by 3. So if you substitute this value is n, then this value also n. Okay, that is a formula. Then solution, given that you have to write, then so this is the formula. So this formula, we have said that 1 plus x whole power n, is it? No, sorry, this one is x power n. This value is nothing but, this value is nothing but x power n, x power n minus a power n. This formula, x power n minus a power n, x power n minus a power n by x minus a. So then, so left hand side value is this one. So for this one, I'm adding and subtracting 1 with the 1. Adding and subtracting with the 1. Please note this ones, children. So this is x power n only. 1 dot, not this one. So x power n minus a power n by x minus a. 1 second. 1 second. Okay, this is a question. So then, given that limit x tends to 0, root 3 of cube root of 1 plus x minus cube root of 1 minus x by x. Then, so this is the formula we have to use. So for that one, you have to transform the value. So transform the values. I'm adding and subtracting with 1 here. So minus 1 plus 1, minus 1 plus 1. So here, so minus 1 plus 1 by 1 plus x minus 1. So I'm writing this value is a, this value is b, and the denominator is c. So I can write a by c minus b by c. So like this. So that is nothing but limit x tends to 0 f minus g of x is nothing but limit x tends to 0 f of x minus limit x tends to 0 g of x. So that one we can write. So from the denominator and the numerator, we have to add and subtract 1. Okay, then this is the value. So this is cube root of 1 plus x minus 1 by 1 plus x minus 1 minus limit x tends to 0 cube root of 1 minus x minus 1 by 1 plus x minus 1. Here, observe this value is minus. Clearly here value is minus. Just don't get confused here. This is minus value, and I'm writing also here minus value, but now here plus value. So how, sir? So here, see this. Take minus common from the denominator. Take minus common from the denominator. Okay, so then you will get this is minus 1 minus x. Minus 1 is there and the minus x is there. This will be plus 1. So plus 1 I'm writing front. So then 1 minus x minus 1. 1 minus x minus 1 as per this formula. Okay, so this is the only one change in the main change in the question. Then this value. So in the previous said that x power n equal to x power 1 by n is nothing but n the root of x. That's why I can write limit x tends to 0 1 plus x whole power 1 by 3 minus 1 power 1 by 3 by 1 plus x minus 1 plus limit x tends to 0 1 minus x whole power 1 by 3 minus 1 power 1 by 3 by 1 minus x minus 1. So as per that formula, so this formula, so sorry again here. Okay, again this formula. Again we are using this formula. So this is cube root of 1 plus x minus cube root of 1 minus x by x. Then simplifying this one. So this value is nothing but this formula. So 1 plus x, 1 plus x. So this is a 1 limit extends to 0 x power n minus a power n by x minus a. So that is the value is there. So then this is 1 plus x whole power 1 by 3 minus 1 power 1 by 3 by 1 plus x minus 1. So this is x, this is a, x a, x power something, x power n minus a power n by x minus a. So same formula is there. So just you have to apply this formula. So n value is equal to 1 by 3 is there. N value is nothing but 1 by 3 is there. N value is nothing but 1 by 3. So using this formula, 1 by 3 into a value is nothing but 1 is there. A value is 1 by 1. So just n minus 1. So 1 by 3 minus 1. So 1 by 3 of 1 into 1 power 1 minus 1 by 3 minus 1 plus 1 by 3 of 1 power 1 by 3 minus 1. Then 1 by 3. So 1 power anything is nothing but 1. So then 1 by 3 plus 1 by 3. So that is nothing but 2 by 3. So this is limit extends to 0 cube root of 1 plus x minus cube root of 1 minus x by x equal to 2 by 3. Okay. So just observe this question, what we are using. Oh. So this is the question. So then we can use the formulas. So that is this formula. So from that one you have to add and subtract with the 1 on the numerator and the denominator, then split into f minus g of x formulas. So then you will get this one. So apply the formula. So this is the form of formula. Then you have to apply, what is the formula? This is the formula. So from that one you will get value as 2 by 3. So next question. So compute limit extends to a x sin a minus a sin x minus by x minus a. So just you have to do same as the previous, but you have to do something values. So here in the previous one you have to add and subtract the value of 1. So here you have to add and subtract that of sin a. So then add and subtract with sin a and the numerator. Then you will get this value. Limit extends to a x sin a minus a sin x by x minus a from the left hand side value. So I'm doing here add and subtracting this value. So there is no change. That's why I'm taking this one. So from this one sin a is there. So from these two I'm taking, from these two from taking sin a common, then I will get sin x minus a into sin a. From these two taking a common, so then I will get a sin a minus sin x, sin a minus sin x by x minus a. So just this is a values, a plus b by c is there. So you can write these values a by c and b by c. So this is, then you will get this value, then you will get this value. So then this will be gets cancelled. Okay, plus a of sin a minus sin x by x minus a. Okay, then so you know the formula sin c minus sin d. In the previous one, 2 cos c plus c plus d by 2 into sin c minus d by 2. So just we have to use here, so clearly you will use that. So sin a is there, in the previous slide only we have the value of sin a. So and so this is a constant term, so writing the outside of the limit, so there is no limit, so you can write this as a sin a only. So next minus a into sin a into limit extends to a 2 cos of x plus a by 2 sin x minus a by 2, that is x minus a by x minus a. Then so use this formula. So then you will get sin a minus 2a of limit this value is cos of this 2 writing out outside the limit, then cos of x plus a by 2 limit this value, okay. So I'm multiplying dividing with 2 here, so from the numerator we have 2, so that's why I'm multiply dividing with 2 here. So that is nothing but like this. So then I can write this 1 by 2 outside, so like this. This is nothing but limit extends to a extends to 0 sin x by x equal to a. So from that one we can use this formula. So apply the limit, this value is 1, so this 2 will get cancelled, a into apply the limit cos of a plus a by 2, so that value, so this is the value. So Sin a minus a into cos 2a by 2. Then sin a minus a cos a. So this is the required answer. Okay. So I'm repeating once again. So what is given that in the question? So limit extends to a x sin a minus a sin x by x minus a. So then we have to add and subtract with sin a for the transform into a formula. So then we have to add and subtract a sin a minus a sin a. Then just you have to take sin a common, then you will get x minus a, and the a common sin a minus sin x by x minus a, and this is the simplification. Then you use the formula sin c minus sin d by 2 cos c plus d by 2 into sin c minus d by 2. So then use, so simplify that one. So this is the values. Sin a minus a limit sin x tends to a 2 cos of x plus a by 2 sin x minus a by 2. Then from the denominator we don't have by 2 is there, but we have to multiply and divide with 2. Then you will get this value. So this value is nothing but 1. Sin limit x tends to 0, x tends to a, sin a x by x equal to 1 a. So then we'll get these 2 will get cancelled. Then sin a minus a cos of a plus a by 2 into 1. Then sin a minus a cos 2a by 2, that is sin a minus a cos a. So this is the required answer. So next, so show that limit x tends to 0 plus. So this is the right hand limit. So that is 2 mod x by x plus 1 equal to 3. So you have to prove that that value is 3. So then given that limit x tends to 0 plus 2 mod x by x plus 1, 2 mod x by x plus 1. So then, so x tends to 0 plus, then x is greater than 0. So whether because of this is a right hand limit, so this will be the positive. So that's why we can take this value, and the mod x must and should the positive value, must positive value. That's why just applies 2xy. So remove the mod, then 2x by x plus 1, where the limit x tends to 0. So just apply it. So xx will get cancelled. Apply the limit. Then 2 plus 0 plus 1 is nothing but 3. 2 plus 0 plus 1 is nothing but 3. This is the answer. Simple. So very short answer. And the next question. Find the limit x tends to 0, 8 mod x plus 3 mod x by 3 mod x minus 2x. Then for this solution, this is the given that LH as x tends to infinity, then x values here, this is the infinity value. These values we are taking positive value. So that's why, so you have to x mod x replace as x, then 8x plus 3x by 3x minus 2x. 8x plus 3x by 3x minus 2x. 8 plus 3, 11. 11x by 3x minus 2x, x. So then 11x by x is nothing but 11. So this is nothing but 11. X will get cancelled. So there is, we don't need to apply the limit. Why? Because of there is no x terms. That's why this value is 11. So the limit of x tends to infinity, 8 mod x plus 3x by 3 mod x minus 2x equal to 11. Okay. Next assignment. So compute the limit x tends to 0 e power x minus 1 by root over 1 plus x minus 1. So here just you have to rationalize these things. So rationalize, then you will get e power x minus 1 by x into under root of 1 plus x minus 1. Okay, so then then you will get the values. Same next question. Limit x tends to pi by 2 cos of x by x minus pi by 2. So just to have to write this value is I square sine 90 minus theta. So from that one minus sine x will be there, then you will get minus 1 value. So transform into x minus pi by 2. That is nothing but cos x is nothing but sine 90 minus theta. So from that one you will get this value. So then limit x tends to a sine x minus a into tan square x minus a by x square minus a square whole square. So then you have to do this value is x square minus a square whole square. Then this you have to separate these values. I square sine x minus a and these values also. Okay. Then this is sine x minus a by x minus a. So then you will get value 1. So and the values will be the tan square x minus a by x minus a square, x square minus a square whole square. Just split the terms. So limit x tends to 2 limit x tends to 2, 2x square minus 7x minus 4 by 2x minus 1 root x minus 1. Just you have to split this term, then you will get cancel one value, then you will get the answer. Okay, 2 into 4 is there 7, then split the value. Okay, then the compute limit x tends to 0, x into e power x minus 1 by 1 minus cos x, 1 minus cos x. Just you have to e power x by x, e power x by x, and the x by 1 minus cos x there na. So then you can write 2 sine square x by 2, 2 sine square x by 2. So then you have to do this one. Okay, x by 2, 2. So just to simplify and get the answers. So all the best, students. This is the limits chapter, totally limits chapter. So most important questions are given here only. So remaining you have to refer from the textbook, and any doubts from this one you have to take your concern lecturer. Okay, so thank you. This is the end of the class for today. Madhu. Madhu.